kind of these little notes here. If you're watching the recording, just pause it and add those two to the bottom of your relationships and triangles flip chart. And then put it off to the side. And I want you to find this page in your packet that you have. And we're going to kind of create a set of notes that talks about all of these special segments in a triangle. It might be helpful to have a highlighter handy. So if you have a highlighter, go ahead and grab one. If you need a highlighter, I do have some of those here. I'll just put them back. I'll put them right here on the note table. If you want to grab one, go ahead and do that. Okay? Want to grab a highlighter? We'll be using the scissors and your little trash cans in a minute as well. So go ahead and find this for me first. Okay? And actually, what you can do is as we go through each of these, you'll see we have median, altitude, perpendicular bisector, and I think the next page has angle bisector and mid-segment. There's 5 total. So on your, what color is this? Vanilla? I don't even know. This yellowish cream colored paper, I want you to list these segments across the top here as well. Actually, let's do it on the definition side. We're going to do definition. We'll do the construction in a minute. But on the definition side, go ahead and fill in. You're going to write median up here in the blank next to the triangle. So what I mean is that right here, you're going to write the word median. Okay, so you can actually fill that in there. And then after that comes altitude. So I want you to fill in that one too. Altitude. And then what comes next on your paper? A perpendicular bisector. Thank you. Angle bisector. And I think the last one should be mid-segment, right? Okay. So if you would, just go ahead and write those things right on there for me. Okay? And then I'm going to have to write the definitions on the card in just a couple minutes. But what I want to do is I want to put it all on one page here. Let's talk about what a median is. So what we're going to do is with our highlighters, we're going to actually, you can highlight it at the end if you want, but we're going to draw in a median into our triangle. Okay? So I'm going to draw a couple in here. Notice it starts at a vertex and it's going to bisect the opposite side. It's going to start at a vertex and it's going to bisect the opposite side. Okay, so I'm just drawing them in. So I want you to do that as well. I'm going to highlight what the actual median is. The median happens to be, so now we're on in our packet page. Okay, so we're kind of putting the vanilla thing here on this page. And we're just going to highlight the actual segment. All of the things that we're doing today, we're going to be creating segments in a triangle. We're actually going to be constructing them as well. But we're going to start with the median. Okay? Some things that we want to look for to make sure that it's a median. Look at that right over there. Is you want to look for congruent marks. Would you agree with that? Because if it's a median, it has to make sure that that side is cut in half. Sometimes it'll say midpoint. Okay, that's okay. The midpoint of the opposite side. Same thing. It also is going to pass through a vertex. So it's going to start at a vertex. They don't always do that. But this is going to start at a vertex. So start at a vertex. We'll come up with our formal definition in a minute. I'm going to have you guys use the books to come up with those in a minute. We're just going to draw them and explain them for now. An altitude is a different word. Anyone ever heard the word altitude before? An airplane. What does it mean when you're at an altitude of 16,000 feet? All electronic delays now, or whatever they say.
Means like the altitude is like how high you are.
The height, exactly. And actually, it's a synonym for height. Anything want to play a game yet? But it's the height. It's the height of a triangle. It's the altitude. And we can draw it in a couple of different ways. I'm just going to draw, starting at a vertex perpendicular to this side here. That little right box means perpendicular. So we're looking for, it's starting at a vertex. And it's perpendicular, so we're looking for a right angle mark. We're looking for the right angle. So we're looking for the perpendicular symbol or the right angle symbol. Okay. Now I have obtuse triangles separate. Because when it's an obtuse triangle, I'm going to kind of draw it a little bit bigger so you can see what I mean. Don't draw this, just kind of look. If I have an obtuse triangle, okay, and I want to draw an altitude from this vertex, how am I going to go to the opposite side and be perpendicular to it? It needs to be perpendicular. So I'm going to kind of just create a segment here. Okay. Is that perpendicular? Definitely not. No way is at a right angle. So we have to think about how I'm going to have to do this. Perpendicular would kind of be like out here. Wouldn't you agree? So we would have to what we call extend the side. Okay? So in an obtuse triangle, the altitudes happen to be on the outside of the triangle. So that's kind of a special case, so we need to say that. So in an obtuse triangle, it's outside the triangle. Okay. For example, we will kind of draw it here. Kind of like that's a straight line. It's perpendicular. Here we go. That's a straight line. Again, what is actually the altitudes are these lines here, okay, what I'm highlighting. So the segments themselves are the medians or the altitudes. Now, in one special kind of triangle, an altitude and a median are the same thing. Only in one kind of triangle. Can you think about what it is? It's an isosceles triangle. Very good. Absolutely. We drew an isosceles triangle. Let's see if I can find one on here. I drew an agreed it's isosceles. Definitely. Not equilateral, but definitely isosceles. If I drew in a segment from the vertex angle, so drawing a segment down here, okay, that segment from the vertex angle, if it's perpendicular, what is it called? What's the name? If it's perpendicular. You gotta know the vocabulary. We just did it. What's it called? Look at your notes. Begins with an A. Altitude. Okay? So that's an altitude, but it's also a median. Okay? Only in isosceles triangles is that true. So we should probably write that somewhere, don't you think? Let's write. So in an isosceles triangle, these are the same. An isosceles triangle, they are the same. Okay? When drawn from that vertex angle. It's a special case, isosceles. And we can't know that unless we know for sure that this is an isosceles triangle. I drew it that way on purpose. Okay, good enough. Now this last one that we're going to look at here on my page, and if you have two more, is called a perpendicular bisector. This one does not start at a vertex. It can, but it does not have to, and often doesn't. So this would be an example of a perpendicular bisector. Let me draw one in. That is a perpendicular bisector. I'm getting ready to highlight here. This is a perpendicular bisector. Notice where it starts. Well, I don't know. Not at a vertex. But what are we looking for? What has to be true? It has to do what to one of the sides? Bisect it, cut it in half. Good. So we're going to be looking for congruent marks. Would you agree with that? Cut it in half, or we're going to be looking that it's a midpoint, something along those lines. And then what else am I going to be looking for? What else is it true? Right angle mark, because it's going to be perpendicular as well. Usually it does not pass through the vertex. It can occasionally. There's one case where it does. So usually it does not pass through the vertex. Except in the one case. What do you think that special case is? When does a perpendicular bisector go through a vertex? In an equilateral or an isosceles triangle. So this same thing here, not only is it an altitude, whoa, try that again. Not, that's not working. Okay, good. So not only is that segment an altitude, a median, but it's also a what? A perpendicular bisector. That only happens in that special case. Okay? So actually, in an isosceles triangle, all three of these are the same line height. So we should probably extend it to be all three. Okay? All three of them are the same. Okay, good. All right, let's go ahead and do the last two. And then I want us to come up with the definitions. Okay, we're going to write the definitions in two places. We're going to write them on this here. Okay, and you're going to draw in an example of each of these and what they are. And we're also going to write the definition here on your paper. Okay, so we're going to write it two places. Question? Sure.
And this is like, would this also be for equilateral?
Yes. Actually, equilateral goes through any angle. That's awesome. And remember, any equilateral triangle is also isosceles. Angle bisector, we kind of already know what that does, don't we? Oh, I didn't pause the whole recording that whole time. But, sorry, please, if you're watching this, but there's your definition, or there's your angle bisector and mid-segment, what we're looking for here. Now we're going to write the definition. All right, so we go ahead and look at the definition of median and altitude, so hopefully these are what you wrote down. Let's just go ahead and draw an example of a median right on here so we know it starts at a vertex. We know that much. And we know that it bisects the opposite side. We're actually going to do the construction on the other side when we cut these up in just a minute. But for now, let's just go ahead and draw these. On the altitude, I do want you to draw another triangle. So over here, if you would, let's draw, I'm supposed to say the word or. Let's draw an obtuse triangle. Remember that in an altitude, an obtuse triangle, it can be on the outside. So let's draw that example as well. Let's make sure I have my correct example. Let's go ahead and just draw an obtuse triangle. Okay? So do that for me as well on yours. And we know that an altitude starts at a vertex and is perpendicular to the opposite side. It may or may not bisect it. We know for sure it has to be perpendicular. Why did I have you create the obtuse triangle? Why is that the special case? What do you have to do to that side? If I want to drop an altitude from this point at the top of the triangle, and I want to drop it down, I have to extend this guy out, don't I? Did we talk about that? So we have to draw the altitude, and it could be on the outside of the triangle, which it happens to be here. Definitions of median and altitude. Here's the thing, if I were you, I'd probably highlight those as well, so we know what the altitudes actually are. If you have your highlighter, that's a good thing. Okay. There's a highlighter right next to me, if you want to borrow one, or you can borrow more. Okay, mid-segment, hopefully that's the definition you guys got from the book. We know that a mid-segment just connects the midpoint of two sides of a triangle. It does have a couple of properties that we'll talk about eventually. Might not be today, but that is a mid-segment. Okay. All right. Another there's two that really weren't exactly in the back of the book. So those were these. Now, angle bisector, we know what it is. We know that an angle bisector is a segment that starts at a vertex and does what? Begins at a vertex and bisects what? Or cuts in half what? The angle that we're going through. So it begins at a vertex, and I hate to use the word bisect because it's in the definition, but what should we say instead of bisect? Cuts in half, that's fine. And cuts the angle in half. So we were going to draw it from here, let's say. The color. I don't care what it does as long as I know those two angles are congruent, right? The perpendicular bisector is a little odd one, so I kind of created my own definition. I said it was a segment that is perpendicular to a side, creates a right angle with one of the sides, and also passes through the midpoint of the same side. So a perpendicular bisector is a segment that is perpendicular to a side of a triangle and also passes through the midpoint of that same side. So if I was going to draw it here, perpendicular bisector. It does not necessarily go to the vertex, but it can, right? It can, but it doesn't have to. So once you've gotten all 5 of these definitions, I want you to cut them up. And we're going to actually physically tape them to your flip chart. Okay? So cut the 5 up. I've got 3 things of tape. We'll have to share them since there are 6, there's actually 7 tables. So go ahead and take your scissors out. I will tell you, use the bottom line to cut them. And that should be helpful, okay? So, in other words, I'm going to just use that last line to cut. That's pretty much what I'm talking about. So, right about here, make this your cut line, okay? Make that your cut line. And so, go ahead and cut them up, and we'll talk about how to take them in a second. So, once you've cut them, once you cut them, I want you to flip them over. So that, in other words, we're going to so. You'll take one segment and you'll turn it over and you're going to call this the perpendicular bisector, right? Perpendicular bisector. I'm going to start with the angle bisector. So I want you to go ahead and flip each one over and write the name. Okay? Angle bisector, median. Just make sure it corresponds. Look at whatever the definition is on the back and write its definition. Flip them over, write the name on the other side too. And then you can tape them. Okay? So once you have them cut out, you can go ahead and I want you to tape the definition on the back side. So I want you to tape the blank triangle up. So we're going to do the constructions on this side. So for example, I'm going to borrow India's for a minute. She's going to call this, on this side it says altitude, so she's going to write altitude right here. And then she's going to tape it in the altitude part, which was right here. Okay, and you're going to tape it right on that line. Are we okay with what I'm saying? Okay? So go ahead and write one and tape on the other side. I'll walk around and help. So what I want to do is I want to create an angle bisector, okay? And we're going to create, and you have to kind of be careful because there's not a whole lot of room on these little triangles, right? So we have to kind of be a little bit careful with how we do our angle bisector. We're going to start by creating an angle bisector from this segment, from that end of the triangle. So what I want you to do is I want you to get your compass, okay? And I want us to create an angle bisector here. Let's see if you guys remember how to do that. Who remembers? I want to create the angle bisector from the bottom left triangle. What do I have to do with my compass? Nope, we're about halfway. That's a perpendicular. I have to put my point of my compass on the vertex. We'll open it up a little bit first. Put it on there, and then do what? Make an arc. Okay, make an arc. I want you to do that. Come on, Madison, put your compass together. Let's go. Open your compass, make an arc. Once I've made one arc, I'm going to just keep the same. I can change the spread if I want. I don't really care. But I have two new points, don't I? I'm going to move my compass to one of those two new points and make an arc in the middle. Move it to the other point and make an arc that's going to create like a little X out in the middle. Okay? You can. You don't have to. Okay? Once I've done that, I'm going to connect them, connect the 2 points, and create an angle bisector. So I want you to do that. You can use the edge of your compass box. Remember that also makes a ruler, a nice straight edge. If you didn't have a straight edge, feel free to grab one. They're over here on the counter. One. There you go. Angle bisector. I want you to also create an angle bisector from the right-hand point. So I'm going to do it a different color, just so I don't get confused, but I don't think you guys have that luxury. But I want to create 2 angle bisectors in the same triangle. Because there's a special name, you guys listening? There's a special name for the point at which the angle bisectors intersect. And NYP students need to know that name. Okay? So what we're going to do, we're going to now create an angle bisector from the other side. So I'm going to move my, compass to this point. I'm going to create an arc across this point, across that angle, I should say. Remember, you want to do your on a flat surface, not on your binders. Much easier. Sometimes easier to move the paper than it is to move your compass, so think about those options. So flat surface, moving your paper, and then I'm going to do the same thing I just did. I'm going to move my compass out to the new point, make an arc, to the other new point. I have to rotate this guy first. The other new point I just made, make an arc, and then I'm going to connect the 2. So you should see this on your paper. I want you to extend both angle bisectors so they do intersect, just like I have here. Okay? They intersect, the 2 angle bisectors. And if you would, if you have a highlighter or a pen or anything, a different color, I want us to highlight or emphasize the point at which they intersect. There's a special name for them, and they are in your textbook, but I'm going to give you one of them. The angle bisector name is called the incenter. So this point right here is called the incenter. It has a special name. Okay? Only in an equilateral triangle will exactly be in the middle. It's rarely in the middle. Okay?
Is that one word or 2?
One word, in center. Okay? It's one word. You do need to know these words, these vocabulary words. Okay? Now, the other angle bisector, if I drew it in from the top angle down, would also pass through that same point. Okay? They all intersect in one one point. I just drew two, but all three would intersect in the same place. Okay? So angle bisectors in a triangle intersect at a point called the incenter. Fair enough. Let's move on to the next construction. Let's construct a median. This one's a little harder. So we need to think about a construction that we already know. We already know angle bisector, that won't work. What does a median do? Middle of what? Of not two segments. It cuts one side of the triangle in half. Do you agree? Do we know a construction that creates a midpoint? Bisected segment. Perpendicular bisector. That's what we're going to do. We're going to use the bisected segment construction. Right? And the median, we're going to do it from, looking at my triangle here, we're going to do it from the same 2 points. Let's start with this one on the left-hand side. Okay, well, I'm going to create the midpoint of these two sides. Okay, I'm going to find the midpoint of this one and find the midpoint of this one. I'm telling you which two only because we're going to run out of room on a paper. I did them ahead of time, right? So I know which ones will fit on here. Does that make sense? So that's why I'm telling you to do it this way. But let's find the median of each of the sides. Let's start with the left-hand side. Okay, no big thing. So let's start with over here. I want to find the middle of this segment. All right. So here, India, is where I'm going to kind of move my compass a little bit, where I have to worry about more than halfway. Would you agree? Because when we talk about bisect a segment, that's what we mean. So you want it more than halfway. And it's going to get a little messy. So rather than make one big sweeping arc, I'm going to erase what I'm about to do. So don't do this part. But remember the construction is basically this. Come over here and do, oh, sugar. I wonder if it did it. I think it did exactly. Anyway. Remember how we did that and we connected them for the bisected segment? Well, that gets real messy real quick. So I think what I'm going to do is I'm going to just do the above and below. Let me see. Okay, so let me show you what I mean. So we're more than halfway. I'm just going to make an arc. I'm going to go more than halfway. I'm going to make an arc above. There we go. There we go. And make an arc below. Rather than make one big sweeping arc, I'm just going to do above and below. Is that okay? Don't you see what I'm trying to do differently? Because I'm just trying to make it less messy. That's all. If you want to do one big sweeping arc, go for it. I don't care. If that's what you're used to and that's more comfortable for you, that's fine. Just have to be careful because it might get a little messy. You don't care if it gets messy? I don't care either. Keep the same spread, go to the other side, and make an arc. Now I have to kind of be careful over here. I didn't go all the way, so I have to make sure that I do that. I'm okay. I just moved my triangle. Wait, I'm confused. What are we confused about? You need to keep the same spread. You have to keep the same spread. That is true. I created, let me just show you. I don't want you to draw the line though. Okay, don't draw the line. All we're trying to find is the midpoint, right? I don't want to draw the line. The line would be the perpendicular bisector though, wouldn't it? That's not what we're creating. We're creating a median. So I don't want you to draw the line. What I want us to do, I'm just going to use a ruler to show you. What I want us to do is I want us, is it going to rotate? There it goes. I want us to, there we go, to find the middle. Do you see what I'm doing here? I'm just finding the middle. I'm using my straight edge to connect my 2 points, and I'm just going to create the midpoint. I'm just going to use I'm going to use a highlighter or whatever I want, and I'm just finding the midpoint. That's all I did. Just make a dot for the midpoint. That's it. The line is perfect. Someplace, use the the median. The median is now the segment from this midpoint to the opposite side, or the opposite vertex. Right? That's what the median is. The median is, or whatever. I'm trying to get to right to that midpoint. Exactly the midpoint. So from the midpoint to the opposite vertex. That is a median. Okay? I'd like us to draw another median now. I want us to draw the median from this side. Okay, I'm going to use a different color just to help myself so I don't get confused up here. And I'm going to draw the median of this side now. Again, more than halfway. Make sure it is. Mine looks like it is. And I'm going to draw two segments. You don't want it to get super busy, then you can just do an arc above and below. And I'm going to make a ruler, use my ruler, find the midpoint now. Anyway, the midpoint, if I'm going to estimate it, you guys do exactly. The midpoint for this one looks like it's about right there. I drew my line to connect my two. And then I'm going to connect them. Draw in the median. I'm going to highlight my two medians. Here's one. Here's one. Here's the other. Kind of got messy, which is why I think the arc above or arc below is a little bit prettier. I'm going to walk around and show you what I mean when I did above and below, so you can kind of see how less messy it got. So much less messy with just above and below. Okay? And you did that. A lot less messy. This has a point, we call it the point of concurrency. The place where the two highlighted lines intersect, where the two medians intersect, is called the centroid. So this point right here, where the two medians intersect, is called the centroid. Okay? Centroid. Everything okay so far? We're done. Yep, you can take that one when you're done. We've done angle bisector and we've done median. Altitude is not that different. We're still going to use the perpendicular bisector construction. So let's do perpendicular bisector since I have it next. That's not a big deal. That's not hard. Perpendicular bisector. Again, we want to bisect these two sides of the triangle. So how would I do that? Same way I did it, except I can't find a midpoint now. Now I'm just actually going to draw it. I'm going to connect them. So it's the same exact construction that we just did. It's just a matter of what we connect now. So I'm going to make a mark above. Make a mark above. Make an arc below. Come over here and make an arc above. And make an arc below. There's a problem with what I've done. Problem is my smartboard is not happy. There's a problem. What's not the mistake, but what's the problem with my construction? It didn't intersect. I have to make it longer. That's all. Not a big deal. Come back up here. Rotate it around. Come back up here and just make it. Just make it longer to intersect. That's all. And what I'm going to do is simply connect them, because perpendicular bisectors do not pass through a vertex, do they? So that's your perpendicular bisector. Done. That's easy.
Oh, so I just
You just connect them.
So you don't have to do this on both sides?
Yeah, I want you to do two of them. So we should probably label it perpendicular. Mine doesn't look super perpendicular. Why does mine look so bad? Let's try it again. I don't think it looks really good. I'm gonna go back. Mine doesn't look very perpendicular. Let me try it again. Let me do it from back here.
Yeah.
All right, let's. Well, as long as you do the construction right, I'm not going to count it wrong. But guys, let's go ahead. I'm just going to do it from back here. It's a little easier for me. All right, and then I'm just going to connect the two. That looks not perpendicular either. Why is that so bad? What is my problem? Maybe it's an illusion. I don't know, illusion of my brain. It's supposed to be right. Let's try it one more time. Maybe it's just an illusion. I don't know, but it's supposed to be exact. Hopefully yours is a little bit better. Looks a little bit better than mine, but mine doesn't look perpendicular. All right, then we'll do the other one. I'm going to pick a different color here just so that I can see a different color. I'm going to do the other side. Ooh, look at that. That's pretty. Madison. Focus on what you're supposed to be doing.
I'm already done.
With the whole thing? With the perpendicular bisector? Did you do two of them?
Two. Yeah. I did do that.
So what's the name of the perpendicular bisectors where they intersect? Do you know? It's one of those in-center, circumcenter. All right, so I'm drawing it. Now, perpendicular bisectors also intersect in a point. They intersect in a funny name point. Don't giggle when I say it, because although it sounds like something else. It's called the circumcenter. Okay, go ahead, giggle, giggle. Not circumscribe, circumcise, whatever. It's a circumcenter. So far we've done the in-center. We've done the centroid, and we've done the circumcenter. About 10 more minutes, we can get through it. Altitude is the next one. Okay? I think altitude is one of the harder ones. Because altitude has to start at a vertex that's perpendicular to the opposite side. So we have to actually find the midpoint again. Okay? To me, this one's a little bit harder. It's easier for me to do it from the back here. That's what you would. I'm going to sit back here and do it. But let's look at this altitude here. So let me pull up my compass. Okay. Preferably not do that. All right. I have to find the midpoint. I'm going to find the midpoint of these two sides. Actually, I'm not doing midpoint. I don't care about midpoint, do I? I just care about perpendicular. It's perpendicular from a point not on a line. So for example, let me show you what I mean. I want it to be perpendicular to this side. I'm going to erase this in just a minute. I want it to be, no, we don't need to find the midpoint, because we need to find, this is why it's confusing. Let me show you. The altitude, it has to be perpendicular to this side, but pass through that point. Right? So I have to do the construction perpendicular through a point, not in a line. So I'm going to erase those highlighters so you can kind of see what I'm talking about. But I am going to start, I'm going to start by putting my point here. And I'm going to open my compass far enough so that, let's see if I can get my compass to work. Mine might not work up here. There it goes. I have to intersect, that's not going to work. Hang on. I have to make it wide enough. Let's move it. Your compass, I know it works for yours because I did it on my own paper. You open your compass far enough so you're creating 2 points of intersection. What do you notice though? I have to extend the one line. You're in the top left, the left side. So the left side. I want, there's a reason. Okay, that's what you mean. I'm just saying. You want to extend that side a little further for me. Okay? So notice how I had to extend that triangle? You'll have to do that too. Okay? You probably just made the spread a little bit too wide. Just try to get a little bit smaller spread. So now, if you remember, I have these 2 points, and I'm going to create the angle the segment bisector of those 2 points. Okay? I have to extend the line. I have to extend it. So, what I'm going to do is I'm going to create, remember, I'm going to make sure that I'm more than halfway. I'm not more than halfway right here, so I need to make it bigger. And I'm going to make an arc below and an arc above. I'm going to come over here to the other side, and I'm going to do the same thing. Make an arc above and make an arc below. Keep grabbing the wrong thing. This one's not long enough, so I need to make sure that I extend it a little bit here. I just went over here. Right? And then I'm going to connect from here. I actually don't even have to do 2 of them because I already have the 1 point. But I'm going to make this big long thing the altitude. So the altitude goes from here. I don't have to go all the way. I can. But this should be a right angle. Okay? I made an altitude. Good. So now you're going to go ahead and bisect this segment. So it's more than halfway. Right? Make an arc here. You don't want to do it go through here. You need to connect those 2. Yeah. Okay. Let me redo this. Let me redo this one real quick so we can see. So watch me real quick. I'll redo it so you can see what I mean. Yes, because you have to find the point of concurrency. Is everyone okay with this part where I just made the arc? No? Okay. What I need to do is I need to put, because I have to create perpendicular to this side, I'm passing through this point right here. So I'm going to create this arc down here. So I'm going to put my compass on this point, and I'm going to open the spread of my compass enough, where mine has to get really spread, where if I draw the arc, it intersects it in 2 different places. And then these 2 points here are the points I'm going to use from here on out. I had to extend this side of the triangle to make that happen. stop moving that one. So what I'm going to do now is I'm going to bisect this segment here. I'm going to put my compass here, open it more than halfway. Open a little bit more so it's more than halfway. I'm only going to make an arc up here. I don't need to do one down here because I just need one more point because I'm going to pass it through this, aren't I? It's going to go like this. So I already have one point. I just need one more. So then I come to my other point I just created. And I'm going to make my little X. And then I just simply connect those two things. Like that. And that's the altitude.
So what's the point called where they intersect?
The point where two altitudes intersect is called, there's my flip chart. It's called the ortho center. So the ortho center. So let me draw the one real quick. Let me draw the other one here, really. So the other altitude, I'm gonna just make it right from here. Maybe I am, maybe I'm not. I had to extend this one as well. Anyway, let me give you your homework. Okay, we'll come back and finish these up next time. But this is called the ortho center. In your packet, you're going to do at the bottom, page 9. So it says special segments and triangle review homework, page 9. I want you to skip this side, and I want you to skip to the next page, which is page 8. So realize they're out of order. Okay. 9, right? 9. And then 8. I know it says 8. They're out of order. Okay. Basically, it's just a segment homework, folks. Okay. It looks just like this. It's the 2 pages that have this stuff on it in your packet. Okay. Please put the scissors back in the trash can. Please go ahead, and if you use your glue stick, or if you would also put the books back up on one of your desks, stack them up for me. So you have a quiz next class. See you then. We ran over today. Extend your line. You have new points. All right, so then we're going to make an arc down
Where's
here.
the best place for me to put these?
Give me 1 second. Let me finish my video here because Reese is going to be watching it. Oops, you know what I didn't do is make it more than halfway. Hang on. So let me go back. Why is it being weird? There it goes. Okay. I'm going to change colors so I don't get confused for myself. Let's make this one blue. Now, I'm going to make sure that this is more than halfway. It does not appear as though it is. So let's make it a little bit bigger so it's more than halfway at that, and it is now. So I'm going to make an arc down here. Really? Take my compass, there we go, and make it over here. Always nice when it works. There we go. Make my arc down here. And then I'll connect those from the vertex of the triangle through that point. So the point at which the altitudes intersect, this point here, okay, in this case, is called the ortho center. So this point right here is called the ortho center. I'll go ahead and draw a little arrow to it so we know that's the ortho center, the point at which they intersect. So you have a quiz next class on all the vocabulary, on all of the names of the points of concurrency, circumcenter, orthocenter, centroid, incenter. And then you also need to know all of these definitions, the perpendicular bisector, angle bisector. Basically, you're going to have to be able to identify them in a picture like this and identify the incenter and the circumcenter and the orthocenter. Just basically identify them. You won't have to construct them on the quiz. Okay? So your homework is going to be to do page 8 and 9 in your packet. They are a little out of order in your packet, and you have a quiz next class.